Alright. Okay, so number 2, there we go. So number 2 was very long because there were so many angles that you had to find. Thank you. That will help. Okay, for the first ones, those 3 that they asked you about were just 90 degrees each. It was because of angle and semicircle for that one. Same thing, QRT, also angle and semicircle. And then 2.1.3, QTU was that angle over there. I did draw it in, the 90-degree angle is just very small because there is already a K there. And that was because of tangent perpendicular to radius. Any questions on those first 3? Then after that, I'm sure there were multiple reasons that you could have used. I think you did have to do them in that specific order. So from A to N and then W, X, Y, and Z. But especially as you get further down, because you have so many angles already, there are multiple different things that you could have done. So if you want to check your reason, you can just ask me. But those are the values, I think, unless I made mistakes. But I think they should be those values. I'm just going to go down so that you can see all of them. Sure, they don't even all. Okay, that's just all of them. Yes. For B, so for B, oh yes, sorry. So I struggled to see that one quite a bit. So this was 31 degrees. So I think A is an easy one to see that that's tan chord theorem. But then angle B is actually also subtended by that same chord. It's just like very much to the side, right? Because B is that little one over there. So tan chord theorem, the angle between the tangent and chord PT is 31. And then chord PT subtends A, but it also subtends B. Okay, a very difficult one to see that one. Does that make sense? Yes, you could have done that. That's fine. Yes. Yeah.
All tangible things are all 3 of the points.
Yes. All right, so for B, you could have said angles in same segment because of A and B both being subtended by the same chord. So I'll add that there. All right, I'm just going to move down again. Please let me know if you had other reasons that you want to check, or if you maybe got to a different answer. I didn't check my answers at the back of the book, so I hope that they are correct. For I and J, I didn't use reasons for those because I just knew that it was a 90-degree angle and I had the other 2 parts of that angle already in both cases. So I was the third one of the 3, so I just said 90 minus the other 2. And then it was the same thing for J. So there isn't actually a reason for that. Yeah. Yeah, so that was, so it was angles in a angle in a semicircle, but we said it already in the beginning. But yeah, you definitely could have written it again. That's fine. I will post this solution or the solutions again with today's announcement. So if you don't have everything, it will be up. Yeah.
Is the reason for when, like, you have all 3 angles around, like that, like that. Is it angles of revolution or is it angles around a point?
It can be angles around a point or just revolution, just the word revolution. Any questions? Any queries there? And guys, wherever I use exterior angle of a triangle, if you remember, the exterior angle is also something that we often don't recognize. It's something that I also miss quite often. It's fine if you do angles on a straight line and then angle sum in triangle. All right, you will get the same answer. It's just obviously 2 steps instead of the 1. So I used exterior angle of a triangle for W and for X. But for W, you could have also just done angle sum in triangle. And there, yeah, it's fine if you had different reasons. Yeah. Mhm. So for parallelogram, the opposite sides will automatically be equal. The thing that makes it a rectangle, and I still look for a list for you guys, sorry, I keep forgetting, is that the corner angles, the interior angles are 90 degrees. So you actually only have to prove that one angle is 90, because if it's a parallelogram, then those two sides will be parallel. So if this angle is 90, this one will have to be 90 because of co-interior angles. And then these sides will also be parallel. So if this one is 90, then this one will also. So if you just have one 90-degree angle, because all the sides are parallel, while the opposite sides are parallel, it will make all the angles 90. Okay. All right, sorry, I'm actually, you see why I haven't done it, because it's not on my list. That is why. So grade 11 quads properties. I'm writing it on my list. Okay, guys, can we move on to number 4? Or number 5, actually, sorry. Okay, number 5 was very different from the ones that we've done before. Now they were asking us for lengths of sides. Usually we just asked about sizes of angles. So they told us that the radius of the bigger circle is 37 and the radius of the smaller circle is 13. Then the first question was, how far apart are the circumferences of the two circles? So if that radius is 13 and this radius is 37, right? The difference between the two radii will give you the actual difference or distance between the two circumferences. So if you had this, for example, let me just draw it somewhere else, ruler. Okay, I'll have to use this one. I'm just going to draw a radius there. This whole radius there is supposed to be 37, right? The whole one is 37 because they told us the radius of the big circle is 37. But the radius of this short, or not short, smaller circle is 13. So the distance between the two circumferences is that, which is going to be the whole length 37 minus the 13. Does that make sense? Right, so that is why it's actually 24 units apart. Because if the whole thing is 37, that part is 13, then the other part would have to be 24. Obviously, it's not drawn to scale, okay, but that is how you would have to calculate that one. So 5.1. It's okay if you couldn't get that because you didn't actually have to use it again going further down. So that was quite nice. For 5.2.1, they asked you to find the length of FH. So what I did was I actually drew in that radius there. Okay, that radius wasn't given on the diagram. This one. And then it also does kind of look like this is 12, but this was actually 13. 12 refers to this side. Okay, let me actually just erase it there. It's a bit ambiguous in that spot. Okay, that's better. Right, so they told us that OH was 12, and they told us that the radius of the smaller circle is 13. So if we have that, and we obviously know that OH is perpendicular to FG, so this is a right angle triangle, then we can work with Python, right, to get FH. So that's what I did there. So that FH squared is 13 squared. This was the radius. That's where the 13 comes from. Minus 12 squared, that's OH, the length that they gave us. You will get 25 as your answer, and then you do the square root of 25, which is FH. Then for 5.2.2, they asked for the length of DH. Now you have to draw in another radius, but now DH, for that radius, you have to draw in the one of the bigger circle, all right, in order to actually create a right angle triangle. So there again, you have 12. That hypotenuse now is 37 because that's the radius of the bigger circle. And now you can calculate DH using Pythagoras. So now it's 37 squared, right? The radius that we constructed there, minus 12 squared. You write your reason Pythagoras, you square root that, and you get 35 units. Then the next question was asking, yes? No, you don't have to say, well, yeah, you don't actually have to say it, it's fine. All right, then 5.2.3 DF. So we have that is 35 and that is 5. So the rest, DF will have to be 30. Okay, so it was just saying 35 minus 5 is 30. Obviously, this one is now using your answers from the previous two questions. So they would see A there. 5.3, they asked for the lengths of OM and OE. Now, OM is actually one that they drew it in, but they didn't write that 13 there. I wrote it in because they say that the radius of the small circle is 13. Are we all clear that OM is a radius of that small circle? So OM would have to be 13. And then OE is also not drawn in, but if we did draw it in there, that would be 37, right? Because it's a radius of the bigger circle. So I just wrote that there, and then I wrote radii. I suppose you wouldn't really have to write that down. Okay, but yeah, if you want to write the reason, then the reason for that would be that they are radii. And then you actually needed to use those two values to find the length of KE. Now, I jumped the gun a bit here. I didn't write down everything that I was supposed to write down from the start, which is why I added some reasons here. Now, firstly, they didn't tell us that this is a right angle triangle, right? They didn't put that 90-degree angle here. Here they did, so we could just use Pythagoras straight away. In this case, they actually didn't. So see, I also made that mistake. I just went and I was just like, oh, Pythag, nice. But actually, we need to say that it is a right angle triangle. We need to give a reason for that. Now, I think they said that KE is a tangent to the smaller circle. Did they say that? Yes. All right. KE is actually a tangent to the smaller circle. And what do we know about a tangent and a radius? They are perpendicular. All right. So this is a right angle triangle because of that, because of tangent perpendicular to radius, which is why I then, afterwards, when I realized my mistake, I realized that I used Pythag before actually saying that it's a 90-degree angle. So I just put that reason in there, but it actually would have been better if you had said, firstly, that OME is 90 degrees, and then put that reason there. Okay, that would have been better if you first stated that and then did your Pythag working. And now I didn't draw in OE, but that's what they asked us in the previous question, right? They asked us what the length of OE is, and we said that it's 37 because it's the radius of the bigger circle. So now again, we have a right angle triangle. We need to find KE. So what we have to do is first we're going to find ME, and then we're going to double it. Why is ME going to be equal to KM? Why can I just double it to get this length? Because of line from center perpendicular to chord, which is what we have for OM, right? OM is a line from the center and it's perpendicular to this chord, so it cuts the chord in half. So ME and KM will have the same length. So if we get ME's length, then it will be the same for that one, and then KE will just be double that length. All right. So there we go. ME squared is this because of Pythag. Then I got my answer, 20 root 3 units for ME. 20 root 3. And now because of line from center perpendicular to chord, I know that KM will have that same length. And what is 20 root 3 plus 20 root 3? 40 root 3. Okay, you obviously could have written this in decimal form as well, which I'm not sure what that is now. Oh, there's my calculator. Let's see quickly. I think they said actually you have to leave your answer in third form. Sorry, yes. I was wondering why I didn't work that out. Okay, so in the instructions, they said leave your answer in simplified third form. Then 5.5, they just asked what kind of quad is OHEM. So OHEM, that shape over there, and it's a cyclic quad, right? Now, it's interesting because all four of those points don't lie on the circumference, but we can see that that angle is 90 and that angle is 90. So the opposite angles will add up to 180. So that is the reason that we use, right? Converse of angles of cyclic quad. Okay, any questions on this, guys? I'm going to give you some more questions to practice now from exercise. Let's see how exercise 7, these ones are from exercise 7, hey? Okay, 2 and 5. Let's see what else I can give you. I actually want to give you 5 and 6 from, maybe I must just do 5. Yeah, from the revision exercise, number 5. Okay, just that one question. You'll see that again, it's 2 circles. The 2 circles are touching in this case. All right, one is smaller, one is bigger. And then they have some information there. And it's working with X's again. Okay, instead of numbers. Then tomorrow I'm going to do that one proof and give number 6 for homework. All right, so if you have time this afternoon or whatever, number 6 will be the next one. So that will be for Friday. So on Friday, we'll mark that. We'll quickly do the last proof, and then we're done with circles. Okay, then we're moving on to trig. Okay, guys, you have a few minutes, 10 minutes. You can start working on that number 5 now.